Hi guys, we're going to do a DC analysis in this video of another common emitter transistor amplifier here, shown in this diagram on the left. It's similar to the one that we did earlier, but this one has a bit of a twist. Okay, so let's get on with it. So obviously the first thing, as always, is to label all the important currents and voltages that are involved so that we are very clear about which side is positive and so on. So this first one is IB, and this one is IC, and this one is IE. So this is an NPN transistor, so that's IE, IB, and IC. As for voltages, so VCC is obviously positive that way. VCE, since the current coming down, so VCE is positive that way. And again, because IC is going down, so RC is, sorry, I just can't seem to draw a straight line. Oops. Draw again. All right. And this is IB, so it's IB is, IB is going from left to right, so therefore VRB is positive in that direction, and finally VBE is positive in that direction. All right, so let's start creating some equations. Okay, so we're going to do the first part. So for the first part, well, we're going to start off just like we did in the previous example. We're going to work out what is the loop equation on the left. That's the left loop, and this is the right loop. All right, because we need to work out what IB is, we need to work out what IC is, so we're going to start off with that side. So if you notice here, this 20 volts VCC is this entire node up there. Yeah, the entire node is 20 volts. So which means that, and this 20 volts is with respect to ground, so that means that this side is actually 20 volts as well. Yeah, so 20 here with respect to ground. So actually there's a this big looking thing is actually a small loop over here. So so left loop equation. So that's just VCC is equal to VRB plus VBE. All right. Since we know everything, we know VCC, we know VBE, so we can actually work out what VRB is. So therefore, VRB is simply equals to VCC minus VBE. All right. So that's 20 volts. So it's 20 minus 0.7 volts. So it's equal to 19.3 volts. All right. Okay, so what's next? So now we know what VRB is. Well, we can actually work out what IB is, right? Because IB is this current that goes through there. So we know this voltage, we know this resistance. So using just Ohm's law, we can work out what IB is. So IB equals to V over R, so VRB divided by RB. So we're going to get, that's 19.3 volts divided by 470 ohms. All right, 19.3 divided by 7. So 19.3 divided by 470. Okay, so that's a pretty big number. That's 41.06. 41.06 milliamps. Okay, this should ring some alarm bells here because IB is typically very, very small in the range of microamps. And suddenly you have a 41 milliamp, something is not quite correct. So let's just move on for now. So since we know what IB is, we know what beta is, we can actually calculate what IC is using the forward current gain equation. So, so we, IC therefore is equal to beta times IB. All right, so that's 100 times 41.06 milliamps, which is going to work out to be 4.11 amps. So clearly that is obviously not right. Okay, obviously not right. So when you have such a huge current flowing through IC, that means there's a huge voltage drop on RC, a huge voltage drop. I mean, if you have 4.11 going through, that's a huge voltage drop. When you have a huge voltage drop, it means that 20, that 20 at the top there, minus this huge voltage drop, you're going to have VC at a very, very low voltage. All right. So let's just continue and just to show that. So let's now work out what is VRC if you were given this kind of values for IC. So again, using Ohm's law, so it's going to be IC times RC. So that's what 4.11, sorry, 4.11 amps multiplied by 2 kilo ohm. Oh my goodness, this is huge. So obviously it's going to be insanely large. 8,220. All right, so 8,220 volts. So I'm going to put a whole bunch of question marks there. That can't be right. All right. Okay, so basically with this kind of voltage, you're going to obviously force. Well, obviously number one, you cannot be 8,000 because your power source is only 20 volts. So where's it going to get thousands and thousands of voltage? So what that simply means is that the VC node is now pushed to well below what the base is going to be, all right, which will make the CB junction forward bias. So in other words, so just put it here, go down here, sorry. So therefore, the VCB junction, sorry, the CB junction is actually forward biased, and therefore, okay, maybe I should say since the CB junction is actually forward biased, therefore the transistor, therefore Q1 is in bold saturation mode. All right, so it's in saturation mode. So what does saturation mode means? Well, when Q1 is saturated, when an NPN transistor is saturated, VCE is going to be 0 volts. All right. So we can assume that VCE is going to be equal to 0 volts, which, by the way, VCE also happens to be VC, right? So VC is this node with respect to ground, and the emitter happens to be ground, so therefore this is also equals to VC. So we can assume that this is the case. Okay, we can assume VC is equal to 0 volts, and that is also VC. All right, so now we can work out the new IC, given that VC is now 0 volts. All right. Therefore, the new IC. All right, the new IC is going to be equal to, again, this is Ohm's law, V over R. Well, what is the voltage? Well, the voltage is just going to be, one end is 20 volts, right? That's VCC. It's going to be VCC minus VC, where VC is 0. So it's 20 minus 0. Therefore, it's going to be, so it's going to be VCC divided by 2 kilo, divided by RC, rather, right? So that's going to be 20 volts divided by 2 kilo ohm. So 20 divided by 2,000 is going to be 10 milliamps. So that's 10 milliamps. All right, a lot more reasonable. All right, so IC will be 10 milliamps. Therefore IC is 10 milliamps. All right, so now with this new value of IC, well, no, so this is the answer basically. So we have a value for IB, which is 41.06 milliamps. We now have a new value of IC, and we also have a value for VC, which is 0. And the assumption we're making is that the Q1 is actually in saturation, and therefore VCE is at 0 volts. All right, so that is done for part 1. Now for part 2. So for part 2, we're asked to find a new value of RB if VC is actually half of VCC. All right, so VC is now half of VCC, which means we need to work out a new IC if VC is no longer 0, like in the previous case. All right. Okay, so so in this case, we're going to say VC is equal to half of VCC, which means it's going to be equal to VC is 20, so half of 20 is 10 volts. All right, so VC is going to be 10 volts. All right. Okay, so now we know that VC is 10 volts, which means it's also VCE, by the way, right? So VCE and VC are 10 volts. So we can now work out the new IC that is going through RC. All right. So the new IC, I equals a V over R. All right. The V is going to be the VCC minus VC. All right. Divided by RC. All right. So that's going to be equal to VCC is 20, VC is 10, so therefore it's going to be 10 volts. So it's 10 volts divided by 2 kilo ohm. All right. So 10 divided by 2,000. So that's 5 milliamps. So we're talking about 5 milliamps. So now IC is 5 milliamps. All right. So with that, we can actually now go back to working out what the new RB should be given this new IC. All right. So let me just put this down to the next line. All right. Okay. So therefore, the new the new value of RB. All right. So therefore, using again using Ohm's law, R equals V over I. V over I. Well, sorry, I need to work out what IB is first. All right, sorry. So we can work out what the new IB is, given the new IC by using the beta equals IC over IB equation, right? So IB is equal to IC over IB. Sorry, IC over beta, right? So that's 5 milliamps divided by 100. So that's going to be 100. So 0.05 divided by 100. It's going to be 1, 2, 3, 4, 6. Sorry, 5 microamps. Sorry, 50 microamps. All right, so that's 50 microamps. Okay, so now that we know what IB is, we can actually work out what RB should be. Again, using Ohm's law. So RB, the new RB, yeah, R equals V over I. The voltage drop will be the same as the one that we had before, which is at the top here. Yeah, VRB is equal to 19.3 because nothing is changing. It is still 20 volts up there. It is still VB at 0.7. It is still ground there. So it's going to be VRB, VRB divided by IB, right? So VRB is 19.3 volts divided by Okay, wait, let me just check again. 5e negative 3 divided by 100 is equal to, yeah, so 1, 2, 3, 4, 5, 6, yes, 50 micrograms, that's correct. 50 micrograms. All right. So 19.3 divided by 50 microamps, what do you get? Uh, 19.3 divided by 50 e negative 6 is going to be equal to 386 kilo ohm. Right. That's the answer. So we now have a new value of RB if VC is at half of VCC. Okay. So until the next video.